Good morning, dear students. Myself, Dr. Priya, and working as Associate Professor in Chemistry, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. In today's session, we are going to study or learn about fuel cells, its introduction, and then example for fuel cells, in which we have two examples in our syllabus. One is methanol oxygen fuel cell, other one it is solid oxide fuel cell. Let us deal with methanol oxygen fuel cell in this session. Its construction, working, and then applications. So let us start with introduction to fuel cells. So generally we have an idea that if any substance is burnt completely in excess of air, then it is able to release energy in the form of heat. That heat energy can be captured and used for various kinds of applications, economical applications, right? That is, when a fuel is burned, the exchange of electrons will take place when the oxidizing agent comes in direct contact with the atoms of the substance which is being oxidized, that is fuel, and the energy is released in the form of heat. So if you notice the reaction, the fuel which is highly carbonaceous in nature, that is, it will have high content of carbon. If it is burned in excess of oxygen, that means it comes in contact with oxygen, it is able to involve in combustion reaction, thereby it is able to release CO2. Along with that, the heat energy will be liberated. Heat energy will be liberated. So all these reactions of a fuel, that means combustion reactions of a fuels, are examples for redox reactions. So in the same way, if you notice a voltaic cell which is able to convert that free energy of a reaction, that is heat, into electrical energy, for which it has to involve in a redox reactions, that is redox system it has to set up. So both are similar. That means if I use a fuel in a voltaic cell as one of the reactants, so it is able to generate electricity due to the oxidation of that fuel without involving in the combustion reaction. So if I treat this fuel with oxygen, it is able to release energy in the form of electricity. So this is nothing but a little bit of introduction about fuel cells, and fuel cells are much more efficient than normal thermal sources, and these are having lot of applications in spacecraft. And if you notice, the difference between this normal conventional batteries and fuel cells is, in normal conventional batteries, what we will do is, we will store chemical energy, but in the case of fuel cells, we have to supply the fuel continuously without any stop, or we can say any disturbances. That means continuously you have to supply the fuel. So as and when that fuel supply it is continuing, it is able to generate electrical energy. And the second most important thing is, it is having lot of applications in spacecrafts. And third most important advantage is, whenever these were used as a source of electrical energy, these are able to produce water as one of their byproducts. So that's why it is having lot of applications. Now let us start with example 1, that is methanol oxygen fuel cell. So it will have low carbon content, and this methanol is easily involves in oxidation. It easily gets oxidizable, and then it has very high solubility whenever you consider aqueous electrolytes. That means water is used as a solvent, it is having lot of solubility. As this methanol is easily involving in oxidation in the presence of oxygen, that is the advantage, using that as an advantage, that property using as an advantage, we are going to construct this methanol oxygen fuel cell. So let us see its construction part. As I told you, each battery it is having 3 major components: anode, cathode, and electrolyte. So in anode and cathode chambers, generally we use platinum electrodes. Platinum electrodes were fixed in anode and cathode chamber. Into anode chamber, we have to allow the passage of methanol. So it will play the role of negative electrode, or we will call it as anode. And into the cathode chamber, oxygen gas it is to be bubbled, or it is to be absorbed by the atmospheric oxygen, that is from air also it is able to absorb, but the electrodes are made up of platinum. And moreover, we have to keep it in mind that these fuel cells are examples for primary batteries. These are nothing but primary batteries, because as and when you supply that content of fuel continuously, it is able to generate electricity. If you stop the supply of fuel, then it won't work like a battery, it becomes dead. That's why these are examples for primary batteries. So as I told you, anode and cathode, these are made up of platinum electrodes, and into the anode chamber we have to allow the passage of methanol, and into the cathode chamber we have to bubble the oxygen gas, or the atmospheric oxygen, it is absorbed by the platinum electrode. Anything it is we can consider. And then electrolyte is aqueous solution of H2SO4, dilute H2SO4 solution we are going to use. So, and its working temperature range, it is from 40 to 90 degrees centigrade. So, let us see the working principle involved, or cell reactions during the mechanism part. So, coming to the cell reactions, that is reactions that were taking place at anode. In the anode chamber, we have allowed the passage of methanol, right? So, that is CH3OH. This methanol is able to combine with the water molecules that were present in the electrolytic solution. Electrolytic solution, it is H2SO4. It is prepared by dissolving H2SO4 sulfuric acid in water. So, it will have water content. So, this methanol is able to mix up with that water molecules. As a result, it is able to release CO2. Along with that, H plus ions and electrons will be released. So, it is an example for oxidation reaction. So, coming to cathode part, that is at cathode chamber, we have oxygen. So, this oxygen is able to involve in reduction, that is by gaining electrons which were lost at anode. So, in the presence of H plus ions, it is able to form water molecule. So, if you notice the net cell reaction, these two things get cancelled. On either side we have. So, here it is 1 mole of water and here it is 3 moles of water. If you subtract, we will get 2 moles of water. So, CH3OH plus 3 by 2 O2 gives rise to CO2 and water. So, as I told you, it is releasing, it is able to produce water as one of the byproducts. So, it is having lot of applications in spacecraft. So, along with that CO2 will be liberated, and its concentration it is very less, and within permissible limits it is able to release the CO2 content. That's why it is eco-friendly in nature. So, let us go with the construction. I am going to show the picture of a miniature form of fuel cell, that is methanol oxygen fuel cell. As I told you, it is having two chambers, one is anode, another one is cathode. So, into the cathode chamber, methanol along with electrolytic solution are allowed to pass, and into the cathode chamber, atmospheric oxygen is allowed to pass. Then immediately what will happen? Anode and cathode reactions will take place. As a result, water and CO2 will be produced. So, during this reaction, it is able to release an output voltage of 1.21 volts. Cell potential, it is 1.21 volts. So, methanol that is having H2SO4 is passed through the anode compartment, and oxygen it is allowed to pass through the cathode compartment. Electrolyte, it is consisting of sulfuric acid, a membrane or separator that is present which prevents the diffusion of methanol into the cathode. It is able to separate both anode and cathode chambers. As methanol undergoes oxidation, it is able to liberate CO2. Along with that, electrons will be liberated. These liberated electrons will be taken by the oxygen, and they get reduced, that is involving in reduction into water. As a result, energy will be liberated at cathode. The acid electrolyte offers the advantage of easy removal of CO2, that is the product of the cell reaction. As I told you, it is able to release an output voltage of 1.21 volts. What are the applications? What are the applications of this fuel cells means? So, these are having applications in fuel cell vehicles, that is for running vehicles we have to depend upon this methanol oxygen fuel cell. As I told you, it is having lot of applications in spacecraft. It is used in any consumables which require long lasting power, that is compared to the lithium ion battery. If you supply continuously, then it is able to generate electrical energy. So, that is the most advantageous thing. And it is also having applications in military side, that is military applications, and in all kinds of portable, automotive and mobile applications like powering laptop, computers, cellular phones and digital cameras. We can make use of this methanol oxygen fuel cells as a source of electrical energy. So far in today's session, what I have completed is, I have given an introduction to fuel cells, and then in our syllabus we have two examples. Methanol oxygen fuel cell I explained, and then its construction, working and applications. So, in the next session, we are going to learn about solid oxide fuel cell, SOFC. So it is also an example for fuel cell. That's all for today's class. Thank you so much. Have a nice day.